So imagine your health for a second as like a financial retirement portfolio.
Okay, I like that.
Right. Because we're constantly told by absolutely everyone to invest in the standard, blue chip metrics.
Yeah, the usual suspects.
Exactly.
Yeah.
Keep your BMI in check, don't smoke, watch your blood pressure, eat your vegetables, all that stuff.
The standard doctor's office checklist.
Right. But what if the data, and I mean like massive, undeniable mountains of data, shows that we've actually been focusing on the wrong predictors of mortality this entire time?
I mean, it completely upends how we look at aging because we naturally gravitate toward measuring what's easy to measure, right?
Yeah, the stuff in the intake form.
Exactly. But the variables that actually dictate our survival and specifically how long we remain highly functional, well, they're usually operating completely beneath the surface.
And that is exactly what we're getting into today on this deep dive.
It's a really exciting one.
It really is.
Hmm.
Our mission today is to unpack this incredible stack of medical research, massive meta-analyses, sports science data. We've got stuff from the UCLA Med School, Mayo Clinic, DexaFit.
A ton of really rigorous data.
Yeah, and we're using all of it to find the hidden variables that actually dictate how long and how well you live. We're going to see how dynamic the human body really is, because, as we'll see, health is definitely not just some static checklist.
Oh, far from it. It's a highly responsive system. I mean, the choices you make are constantly rewriting your biological code in real time.
Which honestly brings me to the first thing in this research that genuinely shocked me.
The psychological aspect.
Yes.
Yeah.
Because when we talk about physical decline, we immediately think about, diet or exercise. But some of the biggest, most potent risk factors aren't physical at all. They are entirely psychological.
Yeah, it's wild.
It's honestly terrifying that just like feeling lonely can biologically degrade our immune system.
It really is. But, to understand human health, you have to start at the actual foundation of human survival. Before we can even begin to talk about hitting the gym or changing your diet, we have to look at the psychological operating system that governs your cells.
Okay, let's unpack this, because the UCLA Med School findings here are crazy.
Yeah, so researchers at UCLA identified a process called CTRA, which stands for Conserved Transcriptional Response to Adversity.
Okay, that sounds intensely academic. Like, what does that actually look like in the body?
Well, essentially, they found that the subjective feeling of loneliness literally alters the gene expression in your white blood cells.
Wait, really?
Yeah. When you feel chronically isolated, your body upregulates or, turns up its inflammatory genes. And at the exact same time, it downregulates or suppresses its antiviral responses.
Wait, let me make sure I'm hearing you correctly.
Yeah.
Just the emotion of feeling alone
Yeah.
changes how my DNA tells my immune system to behave.
Precisely. And to understand why, you have to look at this through the lens of evolutionary biology. Because historically, right, thousands of years ago, if a primate was isolated from their troop, their primary threat was no longer catching a virus from another primate because they were alone.
Oh, right, because there's nobody around to catch a cold from.
Exactly. Their immediate life-threatening danger was getting attacked by a predator, sustaining a wound, and dying of a bacterial infection.
Ah. So wait, the isolated body is essentially bracing for impact?
Yes, exactly that.
I mean, I guess if I use an analogy, it's almost like loneliness is this hidden software bug, right? It's just quietly rewriting our immune system's code while running in the background.
That's a great way to put it. It's preemptively ramping up inflammation to fight off a potential bacterial wound, and it drops the antiviral defenses to conserve energy.
Because it thinks a tiger is about to jump out of the bushes.
Exactly. It's a brilliantly adapted ancient survival mechanism, but it completely backfires in the modern world. Because when we are, say, sitting alone in an apartment feeling stressed and isolated,
the body thinks we're stranded in the wilderness.
right, our bodies are preparing for a tiger attack that is never coming.
That is wild.
And researchers actually proved this dynamic by looking at rhesus macaque monkeys, which are, highly social primates.
What did they find?
So the monkeys that were isolated from the group showed elevated levels of norepinephrine.
Which is like the fight or flight chemical, right?
Exactly, the main chemical driver of stress. And this stress chemical triggered the monkeys' bodies to mass produce something called immature monocytes.
Okay, what are those?
Think of monocytes as soldiers in your immune system. Immature monocytes are like overeager, poorly trained rookie soldiers.
Oh, no.
Yeah, they don't know exactly what to target, so they just cause widespread collateral damage in the form of high systemic inflammation.
Wow.
And here is the truly shocking part of that monkey study. When researchers exposed these isolated monkeys to SIV, which is the monkey equivalent of HIV, the virus grew significantly faster in the lonely monkeys.
And because their antiviral genes were suppressed by the loneliness.
Exactly. Their bodies had abandoned the viral defenses to prepare for those bacterial wounds we talked about.
So loneliness causes this massive spike in inflammation. And we
Right.
know that chronic inflammation makes people feel, fatigued and sick,
Right.
which probably makes them want to withdraw even more, making them feel even lonelier. It's a closed loop.
Yes, the isolation and the gene expression literally predict each other. It's a biological downward spiral.
And the sheer scale of this problem is laid out in this massive meta-analysis from Brigham Young University.
Oh, the BYU study is incredible.
Yeah, they looked at 70 different studies covering 3.4 million participants.
Mhm.
And the numbers are just staggering.
They really are.
They found a 29% increased risk of mortality for social isolation, a 26% increased risk for subjective loneliness, and a 32% increased risk for simply living alone.
What's fascinating here is the really crucial distinction between objective isolation and subjective loneliness.
Right, because they aren't always the same thing.
Exactly. Objective isolation is literally living in an empty house. But subjective loneliness is feeling totally alone, even if you're in a crowded office or, frankly, a marriage.
Wow.
And both of those carry the exact same biological weight. The body processes both as a mortal threat.
I have to stop you there, though, because there was a specific data point in that BYU study that made absolute zero sense to me.
Okay, which one?
Why on earth would a 40-year-old be at a higher physical risk of mortality from living alone than an 80-year-old?
Ah, yeah, that one.
It just feels entirely backward. Like, shouldn't the older person be way more physically vulnerable?
It is deeply counterintuitive, I agree. But the data is clear. Adults under 65 face a greater relative mortality risk from social deficits than older adults do.
But why?
Well, the exact mechanism isn't perfectly understood yet, but gerontologists suspect it comes down to transition norms and unexpected stress.
Meaning, like, society expects an 80-year-old to maybe live alone or be in a retirement community, so it's less of a shock to the system?
Right. For an older adult, living alone might be a normalized, relatively peaceful state of life. But for a younger adult, severe social isolation often comes with intense psychological distress.
Or they might act out more.
Exactly. It strongly correlates with riskier behaviors, substance abuse, and poorer self-care.
That makes sense.
Regardless of the exact pathway, though, the data definitively proves that a lack of social connection is a literal biological threat. It's on par with smoking 15 cigarettes a day or having clinical obesity.
Okay, so if our minds can so easily break down our biological defenses, what actually builds them up? Like, is there a physical metric that acts as a real shield against this kind of decline?
Well, avoiding disease is important, of course, but ironically, the best predictor of survival isn't the absence of something bad.
Okay.
It's actually a measure of absolute physical capacity. According to huge data sets from DexaFit and the Cleveland Clinic, the ultimate hardware upgrade for the human machine is your cardiovascular engine.
Oh, we are talking about VO2 max.
Yes, VO2
Yeah.
max.
Here's where it gets really interesting, because I know we hear this term tossed around a lot in fitness circles, but I love the way you can think of it as, like, your body's biological credit score.
Oh, that's a brilliant way to phrase it.
Because you literally cannot fake it. You can't just skip breakfast to make the blood work look better,
Yeah.
You can't take a pill to artificially inflate it, and you can't sweat out water weight right before a test. It is pure, undeniable proof of work.
That is an incredibly accurate analogy because VO2 max is the maximum amount of oxygen your body can physically utilize during intense, all-out exercise.
Right.
It is the sum total of your heart's pumping power, your blood's ability to shuttle oxygen, and your muscles' mitochondrial efficiency.
Meaning how well your cells can actually use that oxygen to create energy.
Exactly. It is the truest reflection of your internal machinery.
And the Cleveland Clinic looked at over 122,000 subjects on this. They found that VO2 max actually outperforms smoking, diabetes, and hypertension as a predictor of mortality.
By a very wide margin, actually. If you are in the lowest fitness category, your hazard risk, so your chance of dying from any cause, is up to 5 times higher than people in the fittest groups.
5 times. That is a massive jump.
It is.
And then there's that veteran study in the research stack, the one that looked at 750,000 subjects. They measured cardiovascular capacity in something called MET-Ts, or metabolic equivalents.
Yes, and to give some context, 1 ME is essentially the amount of energy you burn just sitting still on the couch.
Okay.
It's roughly 3.5 milliliters of oxygen per kilogram of body weight per minute.
And what blew me away is that they found just a 1 MET increase in your capacity results in a 13 to 15% drop in your all-cause mortality risk.
Yep.
And that applies across the board, regardless of your age or your BMI.
Every single step up the ladder counts. And, the thresholds are really vital to know here.
Let's hear them.
If your VO2 max drops under 20 on the scale, you are entering the high-risk zone for severe frailty.
Wow, okay.
Hitting somewhere between 18 and 20 is the absolute bare minimum required just to preserve your basic physical independence as you age.
Meaning like getting up from a chair, carrying groceries, or climbing a flight of stairs without having to stop.
Exactly. Basic daily living.
I should note, the research explicitly points out that these specific target numbers naturally differ a bit between men and women.
Yes, definitely.
Largely due to physiological baselines, right? Like
Right.
heart size and natural hemoglobin levels.
That's right.
But the underlying principle that higher capacity equals higher survival holds universally. But I do have a question about this.
Sure, go ahead.
Does everyone really need to train like an elite athlete to get these benefits? Like if I hit a score of 40, which is generally considered quite good, is there a point of diminishing returns where my body just says, okay, that's enough, we're good?
You would think so, but according to the Cleveland Clinic data, there is remarkably no upper limit to the benefit.
Wait, really? No upper limit?
None. The curve simply does not flatten out. The top 2.5% of individuals, the people in the elite category, had an 80% lower mortality risk than the bottom quartile.
That is insane.
The fitter you get, the more protected you are indefinitely.
But I'm assuming you can't build this kind of elite cellular capacity just by taking a casual evening stroll around the neighborhood.
Oh, you absolutely cannot. I mean, walking is fantastic for general movement and mental health, sure, but to build your VO2 max, you have to actively force the body to adapt.
You have to stress the system.
Exactly. You have to push into high-intensity work that makes you breathe heavily. That stress is what forces your heart to pump harder and signals your cells to build more mitochondria. You have to raise the ceiling.
Okay, so you can upgrade the software by managing loneliness, and you can build this massive power supply by pushing your VO2 max. But none of that matters if the scaffolding holding it all together is quietly dissolving.
Exactly right. You need structural integrity, and that scaffolding is your skeletal muscle.
Which brings us to the Mayo Clinic and the Get Back to Sport meta-analyses.
Incredible data in those.
Yeah, they looked at roughly 370,000 participants to see how resistance training impacts survival. And the data shows that resistance training of any amount is associated with a 21% lower risk of all-cause mortality and a 14% drop in cancer mortality.
Right. And if you combine that resistance training with the aerobic VO2 max training we just discussed, so you're actively building both the engine and the scaffolding, that mortality risk reduction jumps to an incredible 40%.
Which is huge. Yeah. But this is the part I was fully prepared to misunderstand.
How so?
Because I assumed you had to spend hours in the gym every single day to get a 40% drop in mortality risk. But the data shows the sweet spot for maximum risk reduction requires shockingly little time.
It really does.
We are talking about 30 to 60 minutes a week, total. 0 to 2 sessions a week literally maxes out the survival benefit.
Yeah.
That almost sounds like a typo to me.
It sounds totally too good to be true, I know. But it acts very much like the minimum effective dose of a pharmaceutical drug.
A minimum effective dose, yeah.
You do not need to be a bodybuilder to reap massive survival benefits. And to understand why it's so potent, you have to realize that muscle does a lot more than just lift heavy things.
What else is it doing?
Well, muscle is actually the largest endocrine organ in the human body.
An endocrine organ, like a gland.
Essentially, yes.
Yeah.
It actively secretes chemicals and communicates with the rest of your systems. Having more muscle mass drastically improves your glucose metabolism.
Okay.
When your muscles contract, they physically pull sugar out of your bloodstream to use for energy, acting as a massive sink for blood glucose.
Which prevents insulin resistance and type 2 diabetes.
Exactly.
So it's doing complex chemical work for me, basically stabilizing my blood sugar just by existing on my frame.
Yes, and it is directly associated with a reduction in visceral fat. That's a really crucial distinction.
Right, because we often worry about subcutaneous fat, right? Like the soft, jiggly fat right under the skin.
Right. But visceral fat is the hard, toxic fat that wraps deep inside your abdomen, literally suffocating your organs like the liver and the heart.
And that's the dangerous stuff.
Very dangerous. Visceral fat actively pumps out inflammatory cytokines, but building muscle shrinks that dangerous visceral fat layer.
Okay, but if building muscle is this incredibly protective for our scaffolding, why do I see so many older folks at the gym putting in the work, lifting weights, but still looking frail?
Yeah.
Like they are clearly trying, but they are still losing muscle mass.
This raises an important question, and honestly, it's heartbreaking because it's not a lack of effort on their part at all.
What is it then?
It's a profound biological roadblock. Gerontologists refer to this as anabolic resistance.
Anabolic resistance.
Right. Building muscle seems incredibly straightforward when you are in your 20s or 30s.
Mm-hmm.
But as you age, your body fundamentally changes the rules of the game. Well, you just cannot fuel a 70-year-old body using the exact same nutritional manual you used for a 30-year-old one.
Why not? Like, what is physically happening in the muscle?
Okay. Think of muscle synthesis, the signal your body uses to build and repair tissue, as being controlled by a dimmer switch.
Okay, a dimmer switch.
In your cells, that switch is a specific pathway called mTORC1. When you are a young adult, eating a modest meal with about 20 grams of protein is plenty to easily flip that switch.
Okay, so the body gets the signal, turns on the machinery, and builds muscle.
Exactly. But in an older adult,
Does that switch get rusted stuck or something?
highly desensitized, older muscle is incredibly stubborn.
Wow.
Yeah, to break through that geriatric resistance barrier and force the mTORC1 switch to turn on, an older adult needs a much larger and far more precise dose of protein.
Like how much?
We are talking 30 to 40 grams of protein per meal. And crucially, it must contain a high concentration, about 3 to 4 grams of a specific amino acid called leucine. Yes, leucine is the biochemical key that forces that rusted switch to flip.
Okay, so the obvious solution for an older adult is to just, eat a massive steak or pound heavily animal-derived proteins all day to get that leucine.
Wow.
But, and here's the crazy part, the research slides detail this bizarre phenomenon called the age-dependent mortality reversal.
Yes.
And it shows that doing exactly what I just said, eating all that heavy animal protein between the ages of 50 and 65 puts you in a massive danger zone.
It does. It's a huge paradox. In that 50 to 65 window, consuming a diet chronically high in animal protein is linked to a 75% increase in all-cause mortality and a shocking 4-fold increase in cancer mortality.
4 times the cancer risk.
Yes.
Just from eating protein. How does eating protein cause that?
It all comes back to that mTORC1 pathway, because the switch that tells your muscles to grow also tells other cells to grow.
Oh, I see.
Right? When you consume heavy animal proteins morning, noon, and night, you are keeping that growth switch turned on 24/7.
And so you aren't just signaling your muscles.
No, you are signaling your immune cells too,
Huh.
specifically cells called macrophages.
Okay, macrophages are like the little Pac-Man cleanup crews in our blood, right?
Exactly. They eat cellular garbage. But when macrophage mTORC1 is chronically activated by too much protein, they become sluggish.
They get full.
Yeah, they stop cleaning up debris properly, and over time, they actually die and turn into what's called necrotic plaque.
Oh.
Yeah, literal garbage dumps of dead cells that build up inside the walls of your arteries. You are over-revving the engine of cellular growth, which in middle age accelerates arterial aging and can fuel tumor progression.
Wait, let me make sure I have this straight.
Okay.
To prevent frailty, we need a ton of protein to flip the muscle switch.
Yeah.
But if we eat that much protein, we flip the plaque and tumor switch.
Yes.
It feels like we're completely tracked.
It does feel that way.
But according to the data, right at age 65, this entire equation violently flipped.
It really does.
So what does this all mean? It's like turning 65 is a biological magic trick where the poison suddenly becomes the cure.
It is a remarkable, sudden pivot in human biology. At age 65 and beyond, high protein intake goes from being statistically dangerous to becoming highly protective.
The mortality curves on the graphs literally cross each other.
Yes, they do.
How does that make any sense at all?
Well, if we connect this to the bigger picture, it comes down to competing risks.
Okay.
When you hit 65, Your risk of dying from sarcopenia, which is severe muscle loss leading to frailty, shattered hips, falls, and the total collapse of your immune system, that risk suddenly dramatically outweighs the cardiometabolic risks of elevating those growth pathways.
Oh, wow.
Without high protein, your skeletal scaffolding crumbles much faster than arterial plaque can form. You must force the muscle to repair itself to survive old age.
So how on earth do you or me or the listener balance this? How do you feed your muscles to prevent becoming frail without accidentally feeding arterial plaque in the process?
The secret lies in the difference between transient activation and chronic activation.
Meaning you want to pulse the system, turn it on briefly, and then let it turn off rather than leaving the switch duct taped in the on position all day.
Precisely. You don't want to be eating heavy, saturated animal meats from breakfast until dinner, constantly bathing your cells in growth signals.
Right.
Instead, master athletes and longevity experts utilize what they call a plant-forward protocol. They use highly targeted post-workout pulses of protein.
And the data highlighted a really specific matrix for this. To get that massive 3 to 4 gram dose of leucine without the cardiovascular risks tied to red meat, they use pea protein fortified with free L-leucine.
Which is an incredible piece of biological engineering,
Yeah.
because by taking pea protein, which digests very rapidly, and artificially fortifying it with pure leucine, you achieve the exact same muscle-building spike as you would from a heavy steak or a huge whey protein shake.
So you forcefully flip that mTORC1 switch in the muscle.
Yes.
But because it's plant-based,
Because it's plant-based, it clears the bloodstream quickly, the spike is transient, you aren't exposing those little Pac-Man macrophages to a prolonged chronic amino acid bath.
wow, that's brilliant.
Plus, the plant matrix comes with fiber and polyphenols that actively protect the endothelium, which is the inner lining of your arteries.
So you get the aggressive muscle growth of a younger person,
Yeah.
but you maintain the arterial protection required for an older person.
Exactly.
A complete hack. But, I mean, any protocol like this comes with necessary safety checks, right?
Always. If you are pushing high protein, especially as you age, you have to monitor the machinery.
Right.
The protocol dictates tracking your kidney function, specifically a metric called eGFR, which essentially measures how well your biological exhaust system filters out waste.
Okay. And you also have to monitor your ApoB.
Yes.
ApoB being the protein that carries bad cholesterol, right? It helps us track if that necrotic plaque is actually forming in the arteries.
Exactly. It's the ultimate marker for cardiovascular risk. And finally, because a plant-forward diet is brilliant for arterial health, but can lack certain micronutrients, you have to keep an eye on your B12, vitamin D, and omega-3 levels.
Just to ensure the system has everything it needs to run smoothly.
That's right.
Man, this has been an absolutely wild journey through the inner workings of the body. We've gone from the primate mind to the heart to the skeletal scaffolding.
It covers a lot of ground.
It really does. Let's pull all these threads together for you, the listener. What this entire stack of data proves is that longevity isn't just one single isolated metric.
No, not at all.
You can't just fixate on your weight on the scale or a single cholesterol number and call it a day.
True resilience is a highly dynamic interplay. It means tending to all levels of the system simultaneously.
It's keeping your immune system calm and your inflammatory rookie soldiers from running wild by maintaining rich, meaningful social connections.
Right.
It's proving your biological youth through the undeniable, unfakeable capacity of your VO2 max engine. And it's defending your structural scaffolding with the absolute minimum effective dose of resistance training, fueled by precise, age-adjusted protein pulses.
And honestly, the most empowering takeaway from all of this research is that you hold the levers.
You really do.
Whether you are 30 years old right now or 75 years old, your gene expression, your cardiovascular capacity, and your mortality risks are all highly responsive to your daily behaviors. Your body is always listening, just waiting for your instructions.
So as you go about the rest of your day, we want to leave you with a paradigm-shifting question to mull over. We started by looking at your health as a static financial portfolio, right? Just waiting to see what the market does to you.
Right.
But if our very cellular code, the way our DNA expresses itself, can be entirely rewritten just by having a deep, connected conversation with a good friend.
Yeah.
And if a nutrient that acts like a biological poison at age 64 suddenly becomes the very thing that saves your life at 65, what if we stopped looking at aging as a fixed, unavoidable timeline? What if aging is actually a fluid dynamic software program and you're sitting right at the keyboard?